Hey there, welcome back to the channel. Let me show you the benchmark. I have SSH into the x86 Arch machine. I guess it's a DFQ. Let's see, DFQ. Make run. So as you can see, the Rectops SPSCQ is giving like 13,000 operations per millisecond with a 350 nanosecond roundabout time latency, whatever. And our BFQ is 4,820 operations per millisecond. And as you can see, it's taking a lot of time to calculate the uh, latency. So, anytime now, yep, 2,000 nanoseconds, which is around worst case. Like in the worst case, it's nearly 10 times slower, right? Okay, so we need to make it faster. And how do we do that? Let's go. That's what we are here for. Okay, so let's see that's what we are. Sorry, my bad. So blazing the fast queue, we go into BFQ. Cool. Now, wait, this was it. Yep, I guess. Yep. I'll get pull because there are some changes that I did on the machine because I created a make file over there and then also the rectop binary. The rectop binary will not work over here, so if I execute this, it simply won't work. Yep, format error, whatever. So okay, let's try to get this better. If you are able to see, this is a very bad uh, queue, definitely. So what I'm thinking is that this capacity that we get, we can instead create a vector of size t and initialize it. So let's name it BFQ and initialize it to that capacity value. So this will be the size, and we will make it zero initialize, not zero initialize. What should we? With null initialize. I think this should work. Will this work? Okay, let's not keep it for now. So okay, there is no BFQ any longer. Oh, I should rather do this. So I take this over here. And what will this network? So CI vector and we remove this. And here we can write bfq dot reserve capacity. I think this should work, right? Okay, so now for the push logic, it will be something like mm, yeah. First of all, also we can remove the locks. Uh, yeah. Let's keep them for now. I'll remove them later on. So bfq dot push, right? Yeah, cool. Well, it's not pushing anything. We'll have an atomic pointer. We'll have two atomic pointers. So std atomic int maybe start. Let's initialize to 0, and then we'll have an end, and let's initialize. This will be initialized over here. So end will be equal to yep end dot store. Yeah, it's not a simple variable. Why do I forget that? So it will store what should it store? Capacity -1, maybe. Yeah. Also, now this is the cool part. Stored memory order relaxed because it's not important. It's not that important, It can be relaxed. You don't want it to like do anything. Like okay, I don't think I should explain like what is relaxed and what are the different types of memory orders. There are some cool ones. Like there are acquire release, acquire plus release, sequentially consistent. There's relaxed and there's consume, which nobody really uses. But I think it sounds cool, but nobody really uses that. Also, the implementation sucks. So, what are these memory orders? Memory orders tell CPU to not be a B word. Yep, that's it. So CPU tends to do some, there's a word for it, it's a jugaad. So what it does is that it will like procrastinate, not procrastinate, it will try to be smart. And it will say like, oh, I have this instruction that I want to execute, but it's taking a lot of time. It might take a lot of time. It's not present in the L1, So I'll execute the next instruction and I'll keep the current instruction that I will execute and store it in the store buffer because it's going to take some time to push it to the L1 cache, and then there will be invalidation messages going all around the uh, s- uh, all around our system. So it's let's see this. It will take some time. And hence, we are going to use specific memory orders because the default is, if I don't mention this, the default is sequentially consistent. Because of that, all of the operations, all of the atomic operations are visible to every single core. Every single core is forced to like parse, not parse, but iterate the invalidation queue. I'm not going to explain that. I'm not going to get into that. But okay. So it will do n dot store capacity minus one. That's cool. Should it be int? Yup. Should it be unsigned int? Okay. For now, I'm not going to get into that. Okay. But I'll get into that eventually. So okay. Yep. So end store capacity minus one. That's cool. Wait, am I audible? Audible, audible, audible. Recording, recording, recording. Cool. Okay. So yep. When someone says push, what I basically do is that I will. Should I add a check? Okay, so if well, it's a vector, right? Is vector trivially copyable? Like, can I just do mem copy on it? How to force like change vector capacity in C++? How do I do that? I'll just close this tab. Oh, that's a resize. I'm so dumb. Okay. Yeah, you can use the reserve function. Yeah, yeah, yeah. Don't tell me either. I guess be clunky. So let's resize and to yeah, it will resize. So if I should write if end, wait, what does start even mean then? Duh. I should just write pointer over here. Yeah, pointer. Not pointer, but position. No, pointer is fine. Pointer. If 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 bfq dot size is equal to bfq dot capacity minus one. Sorry. Then if bfq dot size is equal to bfq dot capacity minus one, so I should do this. No, I don't think I need this. So if it's equal, BFQ, then we should resize, right? So BFQ dot resize, and we should resize it to. Also, I should keep the capacity over here. So capacity counter, int capacity. Just give me a minute. Okay, back again. So int capacity is initially null initialized. I'll take this. And it looks so weird because it doesn't have a string. Okay, cool. We'll initialize it over here. So capacity, this dot capacity should have a different word. Initial size. Let me go do this. Capacity is equal to initial size. Yep. Okay, and if this reaches this, then capacity star 2. Cool. We are handling the logic ourselves. Okay, so BFQ dot resize capacity times 2. Cool. And then if it's not, then it's quite easy. Also, and then we can just do. Does resize handle? Wait, resize is the container to contain count elements. If count is equal to the current size, does nothing. If the count is greater than 10, the container is reduced to its first count elements. If the current less than count, then additional copies of the team until zero to follow accepted are appended. There is a value are appended. Does vector resize to normal copy? No, it doesn't. I learned that state vector will explicitly call each element's copy constructor during the session, but I understand first that it doesn't use main copy or TLF into the code, which was my first assumption is my understanding correct. So why they needed to implement state vector this way, main copy, and better yet, TLF would be first assumption for the certain talent free area. There's only in terms of copy construction that doesn't mean to copy text types that are used. Okay. Okay. So far, what I understood is that resize doesn't do. But I don't quite understand that. Okay, if I'm initializing the okay, how about this? How about I try it? Okay, I'll create a main.cpp, main.cpp, right? Main.cpp hash include iostream vector. That's how we learn, That's how we roll. So vector. Let's say it's of type int x. No, yeah. Let's say x is present over here. X dot reserve 2. Cool. So let's do stud cout x dot size x dot capacity, and then I will x dot push back from to. So x dot pushback. Wait, does it respect the reserve? I'm just going to try this. 0, 12, 0, 1, and then 2, 2. Cool. So 0, 1, then 2, 2. So it was size was 0, and then capacity was 1, and then when we push back, yep, nice, cool. So okay, so I guess it works. And now if I do x dot is x dot resize. So now the first element is 1 by the way, okay? So x dot resize 10,000. Okay, it's not going to be flying around somewhere, right? Cool. Do this and then store the C out. I should give a specific number, just in case. So x dot pushback 5713. Store C out x0. Also x1. Store handle. I should also add store handle. So how do we add that? S slash the end operation and then I should add, I can just do this. So just this. So capacity is this, and then replace with, so, and instead replace this, divide this, one this, with y, this, and then this. Oh, I messed up, sorry. Uh, y, this, and then y, store and cool. Okay, 10,0057130. What is this zero for? That's this. Yeah, yeah. Cool, cool, cool. So resize does this. So okay, cool. So push back, not push back. What uh, I'm doing it myself, right? BFQ, what is it? Pointer? Yeah, pointer. Pointer is equal to T. Cool, cool. Pop. In the case of pop, we can just you know reduce the counter. Pointer minus this. Cool. Well, okay. We can't just do that, though. What do I do? Wait, it's a queue. That's what. Oh my god. It's a queue. That's the reason that I kept it. Bro. It's a queue. That's the reason I kept start and end. Why do I forget this? I shouldn't have this. Oh my god. So, okay, capacity. I am so dumb. I am so dumb. I was thinking like it's a stack or something. Okay, I forgot. I completely forgot that this was a queue. I'm so sorry. I'm so sorry. Okay. If BFQ dot size is equal to cooler capacity, I don't have to compare sizes over here. So BFQ dot, not BFQ dot, but rather end dot load, end dot load. If end dot load is equal to capacity, we can resize to capacity star to what BFK dot resize capacity into 2 capacity x1 or keep it easy to read. Yeah, this is easy to read. Better. Resize to the new capacity. And when this is done, then we can finally push. Also, why is a function called away? If the push is equal to that, then if you don't resize capacity again, so dumb. I can't wrap my head around like what all things to do because it's getting a bit overwhelming. I mean, it's not much. It's simple program, but still, bfq dot fetch sub. Why do I have to fetch it? Yeah, I can just store. Uh, how do I fetch sub? Okay, wait. It's a not bfq. The atomic hits have the minus equals, right? It's a easier one. So I can just do end. So if it's a pop, then I can just do start plus plus. Yeah, cool. If it's a push, then end plus plus. Yeah. Mhm. What is this? Sorry. If n dot load is equal to capacity, like we reach the point where n is at the capacity, then capacity will be increased, it will be resized, and then we push it. So uh, bfq dot bfq pointer is equal to not pointer, but rather pointer is equal to whatever value we get, and then end plus plus. This is the end. This is the start. When we pop, we just use the start. Yeah, cool. So bfq end is equal to just remove t and then end plus plus. So if you want to pointer to the front, then we can just return one pointer. If not, then bfq return bfq end. Yep. I think this should work. Like it makes sense, right? This does make sense. I think there might be some errors, but okay, let's try this. So get status. Uh, let's make a new branch. How about we do that? Like, let's make a new branch which will like temp. So git branch. So the current branch is new. Yeah, git checkout dash b temp. Git status. Git new dash n. testing, git push, git push, set, upstream. Or I can just do dash e, origin tab. Okay, so you, so I can just git follow you, git and branch. So git. I don't know why. Is this a bug or something? But now that I've pulled it, and there is a new branch called temp, and if I do git branch, I don't see the temp. It's not fully functional. Please return. Okay, okay, okay. So git check out temp. Git status. Yeah, whatever. Oh, yeah, clear is not okay. It's okay. And if I try to make it nothing to be done around, I did git pull, right? Git branch, git log, testing. Yes. This is the main, and this is the temp, which I'm currently in. And if I do git pull, oh, this doesn't make sense. php.h should be modified, and it is modified. So why is it working? Is it because the executables are application? Okay, let's see. Make run. This should give me an error. Yeah, okay, fair. Uh, yeah, I need to implement invalid use of another functions to the vector bfq. Did you forget that this dot reserve, bfq dot reserve, initial size, how to reserve for so bfq, initial size was not declared. Okay, let's fix the simple errors first. So, yeah, okay, there's a spelling mistake over here. And did you forget this? String size, okay, whatever. And front is not a valid thing. Okay, invalid use of null function this. bfq, did you forget this? Dot empty. Okay, bfq dot empty, return null pointer. Yeah, okay. So I need to create a not empty, but I need to do the size minus. So let's so okay. I have something here. So okay, so I'm on here. Okay, cool. So entity, bfq, atomic length. Yeah. So initial size. First of all, yeah, easy fix. And then empty is not a thing. Yeah. So instead, what I can do is ci boom. Yeah. If end minus start is equal to 0, return it value. Yep. Easy fix. Git add, git commit, something, git push, git pull, git clean, git run. Okay, so errors have reduced a bit. So bfq.reserve, reserve. So vector reserve cpp reference. How do we reserve for vector? There should be an example. Yeah, we will address 1, 2, 3, 7, 8, I was asking for hmm, so mhm. Is it because BFQ was initialized or something? So if I do this, would this fix it? Is it considering that it's a function declaration or something? Easy. So SPSEQ, okay, there it is. What operation would cause that? It's the runtime error. Fair. Mhm. So what is the error? Audible, audible, audible. Okay. So BFQ, I can just do changes over there, right? So BFQ, the top. So basically what is happening is that in benchmark we have a runtime error of the RWR. So this happens when we wait, we dot front. Our stuff doesn't have a front function, right? How does it know then? Let's see if we should be uh, BFQ dot edge into main BFQ of type int and x and we initialize it with a capacity of 10. Cool. So if I do x dot push, this is cool. Still see out x dot front, and there's a big difference because it's a pointer. X dot pop, and you return 0. Motion free, iOS tree. So that's the plan over there. Just request and that's simple and yeah. So okay, we get a lot of errors in Europe, and why is that? Atomic image register does not need template type. Hmm. Okay, it's defined in the header. Okay, okay. What will that change? That's quite very easy. We have two, this, this is the atomic. So boom, a lot of errors have gone. Start was not declared in this code, and yeah, Yeah, probably. Assertion. Okay. Oh my God, it's size tag long assertion. There's stop size will not go down. Yeah. Look at this error. I don't understand anything. This is dumb. Vector TP alert size type allocator reference. When does this happen, by the way? Okay. Let's change a few things. Maybe it's because. So okay, let's reduce our main.cpp to just push about that. It's still messed up. So PF2 about we remove any allocations around. And it's good. Good. So we have a main video, and then if I do SDBC x dot start. So tell me the value of your start, and tell me the value of your end. 0, that's good. And when I do x dot push 1, which is correctly left, if I'm correct, is push. If I try to push 1, just in case, well, we can't. Yeah, we can do that. Yeah, it's still compatible with C types. 0, so dimension 0 worked. So this worked, and then we just x dot push did not work. Simple as that. And why is that? Why didn't the push work? Well, if n dot load, which is 0 currently, is equal to capacity minus 1. I should do that. Okay, let's change that. And we have to dot h and diff just my errors. So n dot load is my 0 and is currently at 0. And if it's equal to capacity, so capacity was initialized, so give it a 1, dft 0 is equal to t plus inside. No, we did not reach that. So we are initializing it to this size bft.h. We go over here, capacity, so switch here, initialized bft to a capacity of capacity, and we also verify it from bft dot capacity. How about that? Uh, let's see. Okay, so it was 10, and then if I go over here, so the capacity was 10, the end. So 0. So here, if we go to this, if n dot load, which is 0, is equal to capacity minus 1, capacity is 10. If it's equal to bfq dot end, bfq end is equal to t and end plus plus. How do we do that? No. Outside if, so it's outside if, cool. And so we are messing up somewhere over here. So okay, we are getting near to it. Bfq end is equal to t. So Bfq, which is a vector, Bfq end. Oh, because it's atomic. Oh, okay, it's not implicitly converting the stuff. What? No, this makes sense. No, no, no. No, that. What? This makes sense. So it's out and up load. Okay, and upload 0. So bfp.h. So it doesn't have it. It should be actually this. So if n dot load is greater to that, it's greater than capacity minus one. How what we do? So n dot load is not a type of. Does this work? Do I need type ID something like that? Clearing curse. Yeah, type ID dot name. Yep, type ID dot name. It should be an int, a simple int. Capital type info for that. Yeah, okay. Put it inside on this. Key. It's off type int. That's what it means. This is global. So n dot load is an integer that's easy and is equal to t. And t was that. Okay, for now, we can just do this dot push back to the system. Yeah, okay, it worked. Cool. Hmm. I shouldn't have done that, right? But still, okay. So, BFQ, some, it did not initialize it itself, seriously, but okay, so BFQ, terminate call after throwing an instance, runtime error, and why is that? What are you doing such that it's not even, so we are over here, and it's throwing that error, okay, they should be created, right? BFQ, yeah, cool. Studios, yeah, object, created. It's basically BFQ, initialize BFQ to capacity of this. Object created, is that the reason? If that was it. So initialization to this, object created, and then there was a little time error. Okay, cool. Let's do that over here. We'll remove inside of this of this push back still make it cool. So another nuclear and then we run. Okay, let's find where there is. So the BFQ we go with this for iterations. I'll do the front. I know I'm going to avoid this, but still. Okay, so I0 and I1 and then it stopped. Hmm, why is that? So, the reason would have been, it did a zero while q dot front, and then, okay, how about we add something? So, how about we add something else? So front call, so space out, front call, is going to work for long term. So not front call, but rather, yeah, after it gets long. So, std out start, and then we just enter start, and then end. This should work. This should work. Maybe. Hmm. T dot front, right? It's end minus start is equal to 0. Means they are the same place, then we just return the pointer. Cool. Start 0 and 5 or 6. Start 0, 5 or 6. Iteration 1, start 1, start 1, 5 or 7. Where did the word 540 come from? Where did it come from? Who decided it come from? Hmm. Who is doing that? So someone is calling push on Q. So Q dot. Let's do this. This is single Q dot push. Okay. But it's this Q. It's not our Q. Yeah. So who is trying to push into this? We're just doing in place, I guess. Okay. Oh, did I do any plus plus in there? Did I forget that? Yeah, no, that not. Yeah, okay. I'm just going to do this for now. I should also have this here. Yes, the same. I think in place is the one that's doing stuff. So let's just see that into this. Just notify that. I know it's going to be bad, but you know, gotta find out. There's going to be a lot of in place on the screen. Yep, 29. Strange. Place 29. And since standard output, like if output stream was taking so much time, it was 29, the small number this time. Hmm, strange. Three instances in place to runtime else. Cool. The only thing is that we do have it in place. So yeah, we can just you know, we can just have to use that. This is not going to fix that, but that's still know, it is not going to fix the error. Just give me a minute. Yep, did not fix the error. 276. We remember this time. Okay. Wait. 276. 0. I 1. The templates was called a lot of times. So what is the problem? So Q dot replace is being called. I get that. Let's CPU 1, let's CPU 2. Q dot replace, do doing that. Mm, and this is T. Yep, okay. This is one thread. This is the Okay. Do I need to add a logic in the pop that how about I add this? So I have stuff that. Goes stuff plus plus. I think that might be because of pop too. So okay. So I'll write fine to pop and then so done. This is cool. Trying to pop, but I run. Object created. I is equal to 0. Iteration 1. It's feeling at iteration 2 itself. So I'm not sure. Why. Called after throwing an instance of student error what code out. Are we printing like what the error is? So let's see if it goes here. So runtime error this. We can just add a try block it here. So try this. Try this. So this is the yeah. This is where it ends. This is where our try block ends. Catch exception. This is how we do it, right? Look, catch exceptions. Now this exception type. Now giving numbers exception type. We got all, but it should be considered bad design. Stood exception would be X. How to print exception? It's a really, let us see what the exception is. So, get this. Okay, so its inference is this. Or e dot what? Okay. So yeah, that's what it is talking about. So benchmark is, so go over here and catch string exception and take its reference and e dot what. If I need to encode exception, switch. Maybe I don't know, I remember. Okay, so this should work. Maybe they can see the exception this time. Maybe not. Run and what? Maybe I did not enclose it correctly. Maybe that might be the reason. So, oh, there wasn't the answer on. So I'm so sorry. I'm so, maybe there was no error at all. Okay, so the status should show me the diff. What if I change content potential mark? Just a bad statements, right? I'm not sure. So the reason that we might be getting this is that the reference, so q dot front, still see out. Okay, I did not mean to run that. Sorry. Yeah, apologize. So, make green and run. So, what do we get this time? What do we get this time? What do we get this time? Nothing. Q dot front is 0, yi is 1. So, Q dot front is a reference to the topmost value. And if it is not equal to I, what front is supposed to be? How is it supposed to be equal? Q dot front is 0. And let's get the end. So the values are public, right? So I can just do this. There was an error. And I can just add stuff over here. So let's see how Q dot is dot Q dot start. It's public. Similarly, gas and and go. Okay. Start is one, end is negative one, and then we Q dot front. Q dot front is trying to calculate that is present at DFQ end. Why do we want to take minus one and this is to that? It should be 920 or whatever the previous number is. Yeah. So Q dot front is 602, I 0, start is 0, end is 70, whatever. Q dot front is 602. Yeah, it doesn't make sense. Why should Q dot front be equal to I? So it doesn't make sense. So what they basically do over here is that, sorry, I'm really sorry. So I get CPU1, CPU2 over here. I have two cores have been selected, and then they just loop it until Q dot front is not equal to null, right? Cool. And when it's not equal to null, then we check if it is equal to I. And why should it be equal to I? Well, it's fine if it's not equal to I. Will this cause an error? Yeah, we'll see when that comes. So I is being printed somewhere. Maybe it's intentional. Uh, 17,413 operations per millisecond, which equated with this, whatever, 4,784 operations per millisecond. Last time it was 2,000 something, right? This time it should be somewhat better because we are reserving stuff because of the reserved keyword. I'll look into that, like why is that specific if condition? Like it doesn't make sense to add that. Yeah. Okay, it's worse. That is cool. That is that is cool. It's worse. Okay. So I'll take care of that afterwards. But I'll first look into that, like why is there this specific if condition? Like if they are on completely different threads, then Q dot front will never be equal to I because that thread is independent, right? Like duh. So it is not equal to I, and we are and placing I itself in there over there. Hmm. Maybe if it was sequentially consistent or something, then that makes sense. No, it still doesn't make sense. Why do this? Explanation. Hmm. Hmm. At the end of the program, I'll just print, yeah, let's see how you dot start, you dot end, render, and also I'll print you dot capacity, you dot capacity. Well, let's see what it gives us. Okay. Pure capacity is 2 million. No, it's 20 million. Okay. So this is the start and end where it all ended. This is the Q capacity that we used. This is that. Okay, so I think I'm going to do this at a very weird way. So I had to figure out like why is that error? Why did that cause a lot of time? I think I should learn perf and valgrind. If people say that it's cool, maybe I'll learn about it. Maybe I'll start using perf and some kind of like performance metric or something. So yeah, I should indeed learn like performance monitoring of my code. But okay, for now, thanks for watching this video. They were charming, and I am an engineer of fun. Bye.